Hello everyone, welcome to lesson 6 from the Full-Time GoDev program, and today in this lesson we are going to cover interfaces. Interfaces is a very important aspect in Golang, especially if you're going to enter the industry, and you need to know everything about interfaces. The problem is interfaces can be used in a very broad aspect. There are very common tricks, and I don't want to bury you. That's one of my, I think, one of my unique teaching styles. I don't want to bury you directly into the complex behavior of interfaces. I'm going to cover the basics, so you have a good understanding what interfaces are, how you can use them, when you probably are going to use them, and what the benefit of interfaces can be. But all the complex stuff, I think I have a lesson coming up. I think a lesson or two in the future. There will be more advanced techniques for all these stuff, and I will cover some more interface in-depth techniques. And of course, along the program where we're doing all these projects, we're going to build these JSON APIs, microservices, and all that stuff. And even in the blockchain series, you will see me using interfaces a lot. So by the end of the program, you will know everything you need to know. You will be basically just a copy of myself. Yes. So basically, an interface. How are we going to declare this? Because we actually never covered this interface stuff. Let me quickly find the sweet spot of recording, and that's here. So basically, an interface is very simple. We're going to say, very simple, we're going to say type, and then we're going to give our interface a name, and we could call our interface a storer, right? Very important. Why storer? Is that even a word? I don't know. Is it even in the dictionary? It isn't, but a storer comes basically from the name storage, right? In Golang, it's very important because in Golang, an interface is most of the time being named with the appended, right? So let's say we have, let me quickly do this here. Let me comment this real quick out. So we're going to say storage, right? And if you check this name, and it's very weird that I'm basically going to educate you about the name, but it's very important because this is an actual idiom in the community. It's an idiomatic way how to write your, how to name your interfaces, right? So I'm going to cover it. So basically, you can see this, right? The right? In Golang, in the standard library, you see this all the time, right? You have, for example, the IO reader, right? We also have the IO writer, which you will see me using a lot, right? So you can see it's all right? It's kind of a verb, right? A doer. Man, my nose is itching, right? No drugs, I swear to God. So basically, you see an IO reader, writer, storer, and all that stuff. And that's actually the reason why we are going to call our interface a storer. Very simple, very straightforward. Why are we going to use a storer? Because this is an interface, a repetitive interface I'm using in my projects all the time. If you're going to write backends, microservices, it doesn't matter. A storer is what I'm basically always using, and that's why I'm going to teach you this right now. So basically, type storer, and that's going to be an interface. And then basically, inside of these brackets, inside of an interface, actually, you could, it's kind of the same as a struct, right? Inside of our interface, we are going to describe what the interface can do, right? So why an interface? You can basically think about this. Let me quickly find a good analogy. Let's say a football player, because it was the World Cup not so long ago. Argentina won. Good job, Messi. Right? So, but in football, we have a footballer. Right? A footballer, actually a football player. Right? A football player. And the only thing we know, if somebody comes to me and I don't know this guy, a complete random guy. He comes to me and he's telling me, hey, Anthony, I'm a footballer. Then, what do I know? I know the guy can football, right? I know he can kick a ball. That's the only thing I know. How does he football? I have no clue, right? Maybe he has a special technique. Maybe he's doing some dances in between. Maybe he is complete garbage. Maybe he is the best. We have no clue. The only thing I know, he's a footballer. I assume he knows the rules of football. That's it, right? That's the same thing with an interface, right? We know, in this case, our interface is a storer. So we know it can store things. But how does it store it? We don't know. Is it a MongoDB storer? I have no clue. Is it the Postgres storage? I have no clue. We don't know, right? So that's the same thing, right? So, and a storer, we can describe here in our interface what this storer can do. And for example, most of the time, we're going to have something like get, right? Get. And get will basically get all. Maybe we should do get all. That's actually better, right? So a storer is going to get all, which is basically going to retrieve everything from the database, all users or something. You name it, it can do it, right? So get all, and that's going to return, for example, let's call this an int, a number storer. I'm going to make it more specific, right? A number storer. What do you think it can do, a number storer? Exactly, it's going to store numbers, right? It is what it is. So we're going to get all, and retrieving everything from our number storer will return a slice of integers, right? And in Golang, it's very idiomatic to return errors. And I actually did not cover errors yet. I'm going to cover that in another lesson, right? So we have get all. And get all will basically return us a slice of integers and an error, right? And what is our number storer also going to do? It's going to retrieve everything, but it can also put, right? It can put stuff in the storage. And we're going to say, because it's a number stored, we're going to give it an int. And you can already see, we don't need to specify, for example, number. You could do this, right? Put number, and it's going to return an error, right? It's a very common practice to always return an error. And in Golang, we also have multiple returns, which I also did not cover. But you're going to see all these things are going to come gradually. If I directly dump everything into your face, you're going to get fried, and it doesn't work, right? What I want in my program is that you're going to learn in a very interactive way, a very lightweight way, but we're going to make it more complex over time, right? Hey, and if you have questions, don't hesitate to just ask me, right? Make sure you are in the private Discord. I have an open Discord, of course, where you can learn from other people, but I also have a private Discord channel. It's the same Discord, but it's another channel. If you're not in my Discord, hey, make sure you're in there. Give me a message, and I will add you to the private channels, so you can talk to me whenever you want, right? So we're going to put a number, and in an interface, we don't need to specify the exact variable name here, right? Because it's an interface. We're just describing what it can do. We're not going to do some implementation yet, so it doesn't really matter. So we can actually do this away, right? This is a number store, this is our interface. What can we do with this interface? Nothing, right? Actually, nothing. But why is it interesting? Well, I'm going to give you the exact reason, right? For example, we're going to have a server, right? Actually, let's call it an API server, and that's going to be a struct, right? Very simple. And this API server will have, of course, because if somebody is doing a request to our API server, which we will cover in the backend API JSON lessons, we're going to have some kind of a storage, right? Maybe we have a MongoDB storage, maybe we have a Postgres storage, maybe we have an in-memory storage, something we use to quickly test our applications, and just for development, we just have an in-memory storage, so we don't need to hassle with Docker containers of Postgres and all that stuff, right? So we're going to have in our API server a storage. So we're going to say storage, and our storage, actually, we could do it store, right? And let's make it private, and I will cover that very soon. So store is going to be a storage, a storer. Actually, guys, let me call this number store. And that's going to be a number storer, right? So basically what we are doing, we are telling our API server, hey, I have a number store, and that's going to be an interface. The server is not aware if it's a MongoDB storage, or a Postgres storage, or an in-memory storage. Our server doesn't know that, but he doesn't need to know that, right? The only thing our server wants is a number storer. It needs to retrieve numbers, and it needs to store numbers. How and what kind of database it's going to use under the hood, he does not give any shit about it, right? Because what I see a lot of people doing is, instead of doing an interface here or number storage, they are going to do something like this. They're going to say a number store, right? And that's going to be, for example, an MongoDB store, right? So you can see this MongoDB store is highly coupled to our server. What happens if we, for example, want to use another storage? It can't, because it's going to use this MongoDB storage. And this MongoDB storage is going to have its own ways to retrieve values. It's going to have its own ways to store values with BSON types and maybe JSON and I don't know, right? So it's a big problem. So it's a bad behavior, right? It's hard to test, it's hard to scale, it's hard to maintain. So that's why this direct dependency, we're going to delete this dependency and we're going to make this a loosely coupled system where it's just a number storage and we can do whatever we want with that number storage as long as it satisfies this number storage interface, right? So we have our API server, that's perfectly fine. But if we want to construct our API server, for example, here we're going to say API server, API server is going to be an API server, right? And of course, we need to specify this number store. But we cannot specify it because we only have the interface. We cannot use this interface. There's no implementation. It's a declaration. It's an interface, right? Now we need to have the actual implementation of this interface, right? So we can actually put that inside of our API server. Okay, so how are we going to do this? Well, very simple. We're going to make, how do we implement an interface? That's super easy. The only thing you need to do to implement an interface is to implement these two functions. So we're going to make, for example, we're going to say type. We're going to make our own type again. And we're going to say, for example, a MongoDB number store, right? And that's going to return, wait, that's going to be a struct. What am I doing? MongoDB, yes, it's going to be a structure. And of course, inside of this MongoDB store, we will have some client, some MongoDB client inside of that from a package, right? But for now, we're not going to do that for the sake of this demonstration. We're going to say some values here, right? So enable to implement this, we're going to say func, right? And you know that I mentioned in the previous lessons that we can attach functions to our structures, which is basically what is called in Golang function receivers, right? So the MongoDB number store is going to receive a function. And what function is it going to receive? Well, it's going to receive these two functions, so it implements the number store, right? So we're going to say the MongoDB number store is going to be a MongoDB number store, just like that. And we're going to implement the getAll function, which is going to return multiple returns. It's going to return an integer and an error, right? And we are going to return, in this case, we're going to return a slice of integers, for example, 1, 2, and 3, just like that. And then you can also return multiple values. We also need to specify return here, of course, in Golang that's necessary, and then we're going to say null, right? I also didn't cover null, but you're going to see me use that so much that it's going to be second nature ACAP, very rapidly. So what is null? Null is basically stands for the equivalent of null, actually. Null undefined, something like that. It's not undefined. Null is defined. It's nothing. Null, right? This error is going to be null, right? And I hear some ambulance running by, my bad, but hey, it is what it is sometimes. That's life, and unexpected things, and I hope the girl or guy is okay on the whatever he is, right? Or she. So basically, nil. So for an error, it's very simple. You can see that in Golang a lot. If add is not null, if add is not null, if add is not null. You can see that a lot of times in Golang code. It's basically simple. If the error is not null, that basically means there is an error. If the error is null, that means there is no error because the error is null, right? I hope that makes sense, but I promise you, this is easy peasy. Right, so this MongoDB number store getAll will basically return a slice of ints and an error, and in this case, we are returning a slice of ints, right? 1, 2, 3, and the error is going to be null. Simple. Okay, up to the next function. You're going to say func m mongo. Actually, to be honest, let's do not implement the put yet, right? We only have the getAll. So basically, we can already do this, right? API server number store is going to be this MongoDB number store, and we're going to declare our struct just like that, an empty structure, right? And let's see what's going on here. Exactly. cannot use MongoDB number store. Why? Because, can I actually show it my, yes, number storer? Because the missing put method, right? The MongoDB number store does not implement the number storer, right? Or MongoDB store does not implement our interface or or number storer interface, which have two functions it needs to satisfy. It's the getAll and the put, and the compiler telling us that there is a missing put function. So that's why it's not working, right? So we're gonna do that. We're gonna implement that, and I'm gonna copy this signature real quick here, and we're gonna say put, and that's gonna be an integer, a number. And in this case, we need to specify it, right? Like in our interface here, we can just do int, because number here we can put a number here, right? We can't. It's perfectly fine, but we're not going to use that, right? So int is good. That's most of the time. That's how an interface is going to be laid out. Is going to be the interface signature. But in this case, we're going to put a number, and that's going to be an int. We're going to return only an error, right? Only an error here. And what we can do, maybe we can just print actually here, println. Man, I'm getting a cold, I think. Not quite sure. So we're going to say putting the number. Actually, we're going to make it a little bit better. Store the number into the MongoDB database, whatever. Right. Or storage. Storage. All right. And then we're going to return null. Why? Because there is no error, right? If there was an error, we can return the errors, right? So that's that. And now we can see that it's perfectly fine. So we have our API server here. And what we could do with this API server is we could do API server. And now we're going to call our number store, right? It's a variable we have right here. Where is our API here? API server. We have this number store. So we're going to call this number store from the API. And then we have access to two functions, getAll and put. Because why? Because that's the contract we made. That's a contract the API server made with the number store. Hey, I don't care what you do. I don't care who you are. I don't care how many functions you have. You need to have these two functions because you're a number storer. Simple. And then we can say getAll, and we could do something like the numbers. Right, we're going to say the numbers, but it's a double return. The error, right? Why is it like this? Because it returns two values, right? It returns the slice of integers and an error, just like this. So basically, we can also assign multiple values from that's getting returned from a function. If there were three variables returned, we could do this: numbers r, and then something else, foo, for example, right? But in this case, only two, right? So that's why I do not cover these things all at once, because it's going to overburden you. But here, it makes a lot of sense. So now you could see, hey, oh, that's how it works, right? So numbers are, and then we're going to check for the error. Classic Golang, we're going to say if the error is not null, right? That basically means that if there is an error, because if the error is not null, it means there is an error. So something went wrong. So we need to handle that, right? You could say, for example, panic here. We're going to panic R. Simple. If there is an error, we're just going to panic. If there is no error, right? That's here, no error, right? Then we have the numbers, and then you could say println the numbers, right? Go run main.go. Let's see what's going on. Boom. 1, 2, 3. Exactly, right? Because we returned 1, 2, 3 here, and it's all working fine. Okay, cool. So what's basically the power of the interfaces? Well, you're gonna see. I hope you could see already the power of these flexible interfaces, right? But for example, we have the MongoDB number store, right? And our program is in production, and everybody's happy. And but at a certain time, you can see, oh man, we are running in issues. I don't like MongoDB anymore. Your CTO comes and the CTO tells you, we are running some KPI analytics, and we see that our application is slow. MongoDB is bad. Of course it's not, but just for the sake of, can you please integrate Postgres instead of MongoDB? Can you imagine that you hard-coded your MongoDB here in API server? That would be amazing. That would be nasty because, of course, this is a simple implementation, right? But you could understand that you have a big API with get users and logging and authentication and verification codes, and then you have all these APIs for creating posts and new lists, and oh man, you know, a big API. And suddenly you need to swap out MongoDB with Postgres. I think you're gonna kill yourself because it's a task you cannot start. It's insane, right? It's madness, complete madness to do that. But hey, if you programmed with an interface just like here, if it's just a number store, it's very simple. You say to your boss, yeah, of course, I can do that in an hour, right? It's very simple because instead of this MongoDB number store, I'm going to make a new one. I'm going to say Postgres. How do you... man, I'm so sorry. Postgres. How do you actually write this? Postgres number store is going to be a structure. And as, of course, they're going to be here Postgres values, right? Maybe it's going to be a DB connection or something, right? Connection. But for the sake of this lesson, we're not going to do that, right? And we're going to use Postgres and MongoDB in real later on, for sure. So the next thing we need to do is basically implement, right? Implement these two functions, put and get. So I'm going to copy this real quick from our MongoDB friend, and we're going to change this to this is M from MongoDB store. You can actually call this variable whatever you want. You could call it Postgres right now or something. I'm going to call it P. Or even you could do it S from storage. It doesn't really matter. It's just a variable name, right? And in Golang, we tend to make these function receiver variables very short. But hey, that's up to you. Nobody's going to look you in a bad way if you make this a little bit more verbose and a little bit more readable. But we already know that this S is going to be this Postgres number store, right? And here the same thing. So that's in a non-typed language, I would make this variable, of course, very clear. But if you have a typed language, and especially this number receiver, this function receiver like here, I think it makes sense you could make this a small variable naming, right? So get all, we're going to do the same thing, actually, from Postgres. We're going to return a slice of integers. Could be 1, 2, 3, 4, actually. And maybe, hey, let's do some crazy stuff. You know what, 7, why not? Boom. And store the number into the Postgres storage, right? And so what we could do here, instead of basically saying it's the MongoDB, right? So this is our logic below here, right? Our logic below. So we don't need to touch this logic below. Actually, what we're gonna do here, real quick, is we're gonna also call if R is going to be. This is a shorthand. You can write this as a shorthand, right? You could do, for example, this R is gonna be API server number store we're gonna put 1, right? And then we're gonna say if R is not nil. Of course, we need to handle these errors, right? Some people hate it, but I think it's a superpower because I think the more I'm using Golang over time, the more I like this error handling, and I could swear to God, I would never go back to some other error handling. I just don't like it. This for me is amazing. Of course, in Rust you have these pattern matching stuff, which is also cool, but man, something is very, very bad happened. I can hear the sirens, man. I hope the world is not exploding while I'm recording this. Can you imagine? When this video is done, I go outside and the world is burning. That would be bad, right? That would be bad. Anyway, so we're going to handle this once again. We're going to panic here. If there is an error, of course, in real life examples, when we're going to panic, you're going to see me do a lot of these handling errors in a good way. This is just demonstration way, right? So this is basically the longhand. Let me do a shorthand. We could say if R not nil, panic. This is the same thing, right? And of course, this is, you're going to say, what the hell are you doing? This is a shorthand. You will get used to it. There is no teaching to do on here. I'm just telling you, this is a shorthand explanation, a shorthand written of how to handle these errors. You're going to just, like I said, it's going to be second nature very soon, right? So let's just keep the MongoDB store right now, and I'm going to go run main.go. and you're going to see store the number into the Mongo storage 123, right? So this is basically our logic. And now our CTO comes and he tells us, yo, can you give me please the the Postgres implementation into our complete API? But because you use interfaces, you can just do this Postgres number store and then just run, basically, boom. And we store the number into the Postgres store and we retrieve our numbers from Postgres. Hey, it's that simple, right? That is the power of interfaces, right? So to recap, of course, you can do interface embedding and all that stuff. You probably see that already on my YouTube channel, but we're going to cover all these mechanics step by step, right? I want to make you, especially if you have no experience in Golang or maybe no experience in programming, I'm going to make you from, like I said, from somebody that knows nothing and gradually turn you into a complete knowledge beast, right? That's the way I do things. Cool. Yes, I think this is it for interfaces. Very powerful. An interface is basically just a contract that needs to satisfy a subset of functions. It can be one function. It can be 10 functions. The main goal of interfaces is to make them as short as possible and to make multiple interfaces. For example, 1 to 3 functions in an interface is already more than enough. Sometimes you need more in some cases, but we will cover that because we are going to use interfaces a lot in all of our projects, right? So interfaces need to satisfy a subset of functions, but how they handle it internally does not matter as long as they have these function signatures, right? I'm looking forward to see you in the next lesson.